Are you using .NET and want to get into event sourcing for persisting state? Well, I have a presentation by Jeremy Miller, a maintainer of Martin. Martin is a .NET library that can be used for event sourcing. This entire presentation will show some of the cool features of Martin that really will get you up and running and understanding how it works. And along the way, I throw in my 2 cents and add some comments. Hey everybody, it's Derek Martin from CodeOpinion.com. If you're new to my channel, I post videos on software architecture and design, so if you're into those topics, make sure to subscribe. If you are subscribed and you have watched videos and you have questions, you can chat with other software developers about these topics in my private Discord server. If you're interested in joining, check the links in the description.
So Derek, thank you so much for having me on today. I'm excited for the opportunity to come on and talk about this. Today we're going to talk about the Martin library. What Martin is a library that .NET developers can use to adopt the event sourcing style of persistence, and not only to adopt it, but get started very quickly, and to be able to scale up to some pretty complicated use cases and have some ability to scale up in large data sets as well. So let me kind of jump into a little bit of where it's at. So I'll admit I didn't really know what a Martin was until I did this. I grew up a little too far south. We don't really have them. But that cute guy on the right of the screen, that I believe is a Pine Martin. So Martin itself started about 2015. It's completely open source under the MIT license for the time being. It's a library, but it's backed by PostgreSQL. The reason why that's a great thing, it means right off the bat, you're cloud agnostic. AWS, Azure both have very strong managed PostgreSQL offerings. There's several other cloud providers as well. So you're in good shape there. And not only that, one of the awesome things about Postgres is the Docker image is very, very tiny. So it's very fast to spin up a brand new Postgres database completely on the fly for local development, blow it away when you're done or when you're switching to another project. Martin started out as mainly as an attempt to use Postgres as a document database, using Postgres's really fancy JSON storage capabilities. Postgres has some special JSON capabilities that still go way beyond what other databases like SQL Server, Oracle, or MySQL do. That's still the case. That's why this is built on Postgres. But the original goal of Martin was to, in one heck of a hurry, was to replace another document database we were using in a system that was behaving very poorly. Somewhat because we were using it very poorly, but let's leave the history aside. One of the cool things about Martin that does set it aside from most NoSQL document databases, because it's based on Postgres, we are completely ACID compliant. You can get a very strong consistency between saving a document and being able to immediately turn around and query on the document. If you use some of the other NoSQL databases, you realize that that's actually a big deal. Later on, and almost as a lark, honestly, I threw on some very nascent event sourcing capabilities into Martin. That has taken off. That is where all of the growth and most of the interest in Martin has really been. A lot more people have gotten involved with it since then. So we have a full core team, and it's advanced a lot since then because the initial support was almost nothing. And there's still a long way to go.
Do you think, like you're based on your user base, based on GitHub, is that, you're kind of alluding to it, I guess, is that kind of the main user base is using it for event sourcing, or are they using it primarily for a document store? Like, where do you feel like the percentage is?
Well,
because it has both, so you could be using it for both or one or the other. So
you can mix and match, and more than that. When we get into projected views in Martin event sourcing, just Martin documents.
Yeah.
What I will tell you is, I can't exactly say usage, but I can tell you that most of the GitHub issues, the Gitter questions, the interest, the requests for new features, it seems to be almost all event sourcing. So just real quickly, why Postgres? Because I get asked incessantly for the last 8 years, why did you do this on Postgres? Because many more .NET developers would use SQL Server. Your uptake would probably be much higher if you had used SQL Server. It's fortunately probably all true. Postgres has some, like as I alluded to, it has some very unusually strong JSON support that does go way beyond what is in SQL Server and other databases today, and we leverage that very heavily. And then on top of that, it's a free open source library. It's very strongly supported in other cloud providers. The Postgres project itself, it's a very vibrant community and it's moving scary fast. So it would be nice if we could have done this on SQL Server for uptake, but there's a lot of advantages to Postgres. All right, so Derek and I talked about this ahead a little bit, and I know Derek has many more videos on introductions to the event sourcing. I'll cover this as well, and as well as another Martin core contributor, Oscar Dudas, has a lot of content on event sourcing as well. But if you get past how cute that guy is on the left, again, event sourcing, it's a style of persistence where rather than saving the current state at all times, we're saving the changes. We are purposely saving the events and state changes in kind of an audit, unidirectional audit log. In the case of Martin, and probably most event stores, you're saving it as serialized JSON. So as we get into the real code, you're going to be saving things like, I'm going to talk about a ride sharing system, because I originally built this talk right after my family and I had done a vacation to San Diego and took a lot of Uber rides. Like, you may have a ride requested event, ride started, ride canceled types of events. And those little objects would be serialized and stuffed in the actual database as the full, so you have the full change log. A couple advantages. It's not something I would try to apply to every system by any means. I kind of think of event sourcing as being probably more applicable to workflow-centric applications. But some of the advantages I really like, it kind of makes you or encourages to use the business language. So you're dealing with the actual problem domain in these event names very clearly. I think it makes the code a little easier to trace in terms of what are the actual business requirements happening here. The audit log is very valuable. I've done a lot of work in health. Well, I work for a healthcare software company right now, but I've done a lot of healthcare and banking in the past 5 to 10 years before that. A lot of times they've had formal requirements to keep a persistent audit log of the business transactions that are coming through, why they're changing, debits, credits, changes in patient status, things like that. Event sourcing is giving you a first-class audit log, because that is the actual store of record. Some fancier stuff. What I'm calling temporal querying or time travel, it's the ability, again, thinking of a ride-sharing application. Let's say if you're in the back office and you've had a day where you haven't been able to get enough drivers to the requests, or maybe people have been late, and you want to understand what was going on at 2 p.m. that caused such a huge snarl by 3 p.m. Now, using time travel, we can selectively replay some of the events, and we can recreate perfectly what was the exact state of our ride-sharing world in this city at 2 p.m. yesterday, and then potentially advance it to 3 p.m. to see how things change. So I know there's a lot of other use cases for this, but I've seen this pop up in a few applications where we need to allow business people to troubleshoot, why did things go wrong today? It's also valuable for retrofitting metrics. Another example of event sourcing I've gotten to be a part of was building a system for telehealth. And we needed to get to a minimal viable product pretty fast. So we knew there was going to be a lot of metrics that we probably weren't tracking up front that they would decide later they needed. You know, how long is it taking in this city to go from requesting an appointment to fulfilling the appointment? By storing the raw events, you can actually replay the events to recreate the data for all new metrics that you retrofit in later. So you don't have to think of everything you need metrics wise right now, because you can use the events to find cause and effect, and you can calculate it later. And that's really valuable to allow you to get to a minimal viable product faster without having to stop and think about everything you'll need in the next year. They're not exactly, you can have one without the other. You can do event sourcing as purely a persistence pattern. You can use the CQRS architectural style without any event sourcing, but they kind of go together like peanut butter and jelly, or, if you're a Forrest Gump fan, peas and carrots. So we'll get into a sample in a little while where I think event sourcing fits really well with CQRS. And then lastly, I think event sourcing is actually really valuable for concurrency protection within your system. So far, maybe this is just my opinion, I actually find it easier to deal with concurrency issues when you're using event sourcing, just because the versioning's so easily built in. But I'll let y'all decide if that actually matters.
Yeah, I think the piece that on there that really gets me, and anybody watching my videos knows that I'm continuously harping on your first point, was just in that problem domain that you're working in, it really forces you to think and be talking the language of what's actually happening. When you mention like wouldn't use it everywhere, I completely agree, because in any part of a system, the core of it, I find people naturally talk about things and events. I'm in transportation right now, and if you walked into an office and they just naturally talk that way, if once you pick up on it and you notice it in any domain, I think the core of what people are doing, they just will naturally talk that way.
Just throw some phrase at Derek here. So I watched Derek's vertical slice architecture video last night, which I thought was really good, Derek. But one of the things I think you talked about is maybe bringing a CRUD-centric mentality into systems that should probably be a little more workflow-based, task-based, being built around commands and features rather than trying to structure the whole thing on business entities. So I want to follow right on with what Derek was just talking about the business terms. Let's start to try to build a ride-sharing system. Again, this is the first time I've given the talk, but I originally wrote this right after we got back from a family vacation. But in terms of like capturing the business, the business terms, if you're lucky enough to have a collaborative business partners, you can use the form of requirements gathering called event storming. And I'm going to butcher this a little bit. So the color coding actually matters here. You start, and I got to do this, the time I got to do this with the telehealth system, we actually had the color-coded stickies. So we start out and you try to pick off what are the business transactions or the business events that cause a change of status to the system. And you try to get the business talking. What happens in the workflow? And for rideshare here, so the first things we just think of, it doesn't have to be in order to begin with, but you start brainstorming. Well, the ride has started. So you see that would be the orange sticky here. Or if you're using Miro or something online. Orange box just means some events. So you start rattling off the events, probably start moving these around. So in time sequence, roughly it's left to right is the beginning events to the ending events if you can. And as you identify those events, you can also kind of pair up, and this time it's one-to-one, but it's not always one-to-one. The blue, this is starting to create, as more of a developer, what are the commands? And again, I'm kind of assuming it's CQRS architecture. What are the commands that may spawn these events? And it's not necessarily one-to-one, but let's pretend it is for right now. And then I'm going to add to it, as we discuss things, we're going to talk about what kind of users are in the system. So I'm going to stick these guys in here and there. We have drivers, we have customers, there's probably an admin. And as we keep talking about this, going on further steps, some of the other extensions, The green here, this is starting to think about, well, what views of the state of the system would I need and able to make decisions later on? One thing might be, I want to see the history of a current driver's current shift or his shift on Tuesday. How often were they busy? What were they rated that day? Whatever it was. Or in terms of the current day, if I want to try to assign a ride to all the active drivers, I may want to see, who's had the most drives, who's closer, where are they, what's the current state. So all that, this kind of tells me I probably want a view called driver shift. And I'm going to call that drive shaft at some point in the talk. And then likely probably going to want to have what's more or less going to turn into an aggregate in a few minutes, the ride. My family and I requested a ride to the San Diego Zoo, starting from our hotel at this time, to all the points of when was it routed, when did our driver accept it, when did it start, when did it end, was it canceled, kind of so on and so forth. So to Derek's point about the business logic or the business terms, again, if you have collaborative business partners, this is a great way for them to kind of teach you about how they think about this. They think about the business process, but also to have the code very closely reflect the terminology of the business. First, I need a database for any of this to work. So like I said, Postgres is very Docker friendly, which I really like for any kind of local development. Everybody gets an isolated database, no problems, no fancy stuff with who's what database and the connection string, just spin it up and go. Martin's going to happily take care of all the building out the schema and stuff for us later. So let's forget about the application. If we were spinning up Martin just kind of in a bespoke way, simplest possible way, that's what I'm showing you right here. I need a connection string to a Postgres database, which this is kind of hard coded in here, but this matches the Docker compose file copied from the Martin code base itself. So document store, you're not necessarily going to work with this a lot directly, but for right now, so this spins up. This is a singleton, would be a singleton your system. This would be, it would be more consistent if you came from Hibernate way back in the day. This would be like the Hibernate iSession factory or the document store in RavenDB. Not exactly a one-to-one correlation to anything in EF Core, but let's start the store. This is singleton. I don't need any, we're not going to use any configuration. We're going to use all the defaults. Just go. Then I am going to start a session. Session here in Martin, this reflects a unit of work. This is very analogous to an EF Core DB context. Same kind of concept, scope the same way. This is your unit of work. Now, I'm going to start a new stream. A stream for, I guess, a driver shift. A driver working for Uber or Lyft, starting their day, they clock in at a certain time and say, I'm available with a little bit of information, what kind of car am I? Where am I? Crudely, exactly where am I? So let me take a peek at these classes real quick. I'm working in I think this is .NET 6 or 7. C# records or F# immutable types are really perfect for events. They're small. The events should be immutable anyway. You don't really, once they're captured, you don't change them. You just add more of them. So it's a really easy shorthand. So just showing you what's being captured here. All right. So I'm just going to mark this. Hey, I'm starting a new driver shift. I'm going to tell it what the GUID or what the identity here is GUID. And to be a little bit fancier, I'm not going to get in why, but you probably want to use a sequential GUID. And then I'm going to commit that. And just showing off a little bit. Normally, you just use a session one time, but I could potentially add additional events to the same stream. So I could say, well, now the driver's marking himself as ready at this certain location. Maybe even much later in the day, he accepts his first ride and then pops him in. Of course, that's not any good. You got to be able to fetch him back out. So we could fetch and work with the raw events. It's not that much fun. So we'll get to projections in just a second. But you can get these back out. You can even get all the events at a certain time, a certain revision, whatever it's going to be. Let's see if this actually does run real quick. And we're good. So just showing you a little more context. Part of what I did here at the end is when I pulled out the events, let's just see a readable JSON serialization of what the events were. So you can see this is actually what's giving you a good reflection of what's stored in the database. The table's a flatter version of this, but we're tracking the raw event data itself. What event type this is, we do store the assembly qualified name and an alias for it later. That's all just to be able to help recreate this later. Track what stream does this go to. So a stream is a related set of events. So in this ride sharing world, we're probably going to have a stream for a ride that had multiple events to one identified ride. And then I also set up a driver shift as well.
Yeah, for people that are familiar with this, and they may not be familiar with just Martin, but they're familiar with event sourcing or they've implemented it before, there's a lot of good things that they're probably noticing in that data related to, not to get sidetracked here, but if you are for like the correlation, the causation, the tenant, there's a lot of useful things that you may need that clearly are built in already.
All right, so that's the simplest possible way to append some events. But you're kind of asking yourself, okay, I have all these events. What are they good for? I kind of need to understand where's the driver at right now. I don't want to run through all these events to get there every time by hand. Or what's going on with the ride? I don't want to look at all this raw JSON in the data, right? So let's introduce another concept right after this. So part of event sourcing, and I think the part that probably makes people go, ooh, this is like too much work. It's the idea of projections and aggregations. You got to have projection here. Just means got a facility to turn these raw events into a projected view of this is the current state of the world. An aggregation here, maybe it's a little bit of a specific projection. So for the ride, we want to calculate what's the status of the ride. We want to aggregate all those events into where's the driver now, how many miles have they driven today, how many rides have they've been able to do today, so on and so forth. Before I get into mechanics of how to do that with Martin, I want to talk about the life cycle of when these things are calculated in Martin. This is a place where Martin does things a little bit differently than a lot of other event store tech. Some of you are not going to approve of some of this as well, but still let me get through it. So the projections, we could decide that the projected state of a ride, that we want to do what Martin calls inline. What this means, this is a strong consistency model that as you are trying to capture new events to a ride, the ride started, the ride was canceled, right then and there in the exact same database transaction, actually literally in the same batch command, we're going to quietly go fetch the latest version of the ride. We're going to update it and we're going to persist that as a Martin document. So you have strong consistency between the events coming in and the projected view in the Martin Nice database that you can then pull out at will. Okay. Another option is to do it live. I want to say, I want the current state of the ride. You tell Martin, go get it to me. Martin will go fetch those events in memory. It will calculate the projection on the fly. It will give you the latest status. It'll calculate on the fly. The same mechanism can give you what I was calling time travel before. You could alternatively say, give me version 5, give me the state of the ride at 10 a.m., then again at 10:05, whatever it's going to be. And lastly, Martin supports the idea of asynchronous projections. This is a little more, this is eventual consistency. This is a little more like what you're probably used to in most event stores, I would guess. Asynchronous, what this means is Martin's going to be capturing events as it goes, and rather than make the individual transactions or command handling stop and wait for things to be regenerated, there's a background process that's constantly trying to read new events coming in exact sequential order. And as they come in, find the projected views they refer to and keep them updated. So let me jump to code. We're going to talk about this for quite a while, and I'll try to give some guidance on why you would pick one or the other. So the simplest possible way to do that, I'm going to create a new type called driver shift. This is meant to aggregate all the events for a particular driver on a particular day, and tell you what the state of their world is. Okay, this is just going to be a Martin. This is just going to be a Martin document if we decide to persist it. So I need an identity for this driver shift. This identity, this is actually same as the stream identity. That's important. You know, if you're all seen the movie Blues Brothers, my father's favorite line from that movie is, you know, what kind of music do you have in this establishment? We have both kinds, country and Western. When you're working with Martin, stream identities can be either GUIDs or strings, and that's it. So by default, it's GUIDs, so that's what we're going to use right here. I'll explain where this comes in later, but we're also going to use the version. This is going to be the stream version. Martin is going to magically tell us what is the current version of the driver shift object you're looking at right now. Okay, that's going to come into play a little bit later on when we talk about concurrency protection. So it's going to be a little bit brittle. I'm going to do this as what we call a self-aggregate in Martin. This is simple enough. I can just let this aggregate handle the events itself. So I'm going to say it's constructor that a driver shift aggregate always starts by capturing a shift started event. And you'll see that's exactly how I tried to do it here. So we have a constructor function that will take in a little bit of Martin. This wrapper here gives you a little bit of Martin metadata. You know, so we're capturing events, we're capturing the timestamp the event came in, a little bit of extra information in the raw data itself of the shift started event. So I'm going to start this off. You know, it's just simple properties. You know, what day is this from? What zip code or postal code? Category, you know, something crude. It's big car, small car, XL, luxury, whatever that really means. You know, and tracking a few other things. Now, a strict Martin convention, and let me just say, if you don't like this, it's okay. You don't absolutely have to do this. Make your method apply and take in either the event type or if you need metadata, this would work with the iEvent wrapper as well. Just take that in, and whatever changes you need to do to the aggregate to apply this event to it. So if we get a driver ready event, we know we flip the status to ready, and we update the location to the driver to whatever the event says. You can see there's a few more of these. Now, to forestall a couple questions, maybe this could be, I'm not showing it here. You could make driver shift be an immutable record. And then if you did that, you would return the new version of the driver shift as part of the apply. So you can do immutable aggregates if you want to. Some people do. I've chosen not to because at the time I was writing this, I couldn't exactly remember how to do the record with stuff, to be honest. And then also, you're going to get a little better performance by making your aggregates mutable. Don't tell functional programming people that, but there is a performance cost to using immutability. So, but you got the option. Now let's talk about how to get this out. I'm going to take a quick little side journey and just show you in more of a typical application how you would add Martin to, in this case, a web API, because I'm going to start using this within MVC controllers. So on your service collection, pretty standard stuff. Add Martin. So it's pretty idiomatic.NET now. This is something, just, the side note, this is making, I think, .NET open source a lot more successful now, that there are very common idioms for how you integrate open source tools or extensions into applications. So we're trying to play along with Martin, trying to make it look like all the other tools you're already used to using.
Yeah, I couldn't agree more. It's helping the ecosystem tremendously, that when people are picking stuff up, you borderline don't even need to look at the docs. You can probably guess. You know what I mean? When you're doing configure services or anything like that, it's helped a lot, I think.
We're trying to be a good citizen, and not only that, but the add Martin here, some other advantages of the new .NET generic host builder kind of world. This also allows us to pipe in whatever you're using for logging. This is going to attach the .NET iLogger to Martin itself. So you're going to happily get Martin tracing, Martin errors. We get to the asynchronous stuff. But any place where Martin needs to trace information or it debugs out the actual SQL statements being running, you don't have to do anything to attach logging to Martin. Just whatever you use for iLogger, whether it's SAQ, inlog, whatever it is, console logging, it's all good. Martin's able to use your iLogger. That's awesome. I'm old enough to remember the days when every open source tool had a, mytool.inlog, mytool.log for net. It was garbage. Okay, sorry, long-winded. There we go. We're going to add Martin. I'll talk about some of the other stuff later. So let's look at a controller. So let me do this kind of a long way around. Let's say in this case, we have a small command where we want to say, accept the ride. The driver has decided that the system has tried to assign a ride to him, and he says, yes, I can do it, or he or she. Accept the ride, click, I can do this. So I need to grab a couple things. I need the command itself. That's going to come from the body. And then the document session, this is the Martin session we were using before. This is our unit of work. So this is longhand. I'm going to come back and we're going to do this a little bit shorter later. So if we said, with no other configuration, that I just want to calculate the driver shift live right at this time, I'm going to pull the aggregate out so that I can make decisions on whether or not I can do this. So in our command, once we have this aggregate, we can use the state of the aggregate to say, is it really valid for this to happen here? Maybe in this case, just simplistically, if the driver is not already marked as ready, then he can't be accepting rides. We don't want him to accept a ride when he's already busy or something, maybe, right? This is probably a bad example. Lyft people are probably making fun of me here. But so you can see a little validation. And then once we say we're good, I want to tag in another ride accepted event and apply that to this stream. So the same events.append. I'm going to tell it what the stream ID is for this driver shift. A little bit more I'll get into in a second. This is a little bit of optimistic concurrency protection I'll talk about in a little bit. And finally, the event, save the changes. So this is if we're assuming we're going to let Martin just build this aggregate up for us on the fly from the raw events. So this is an example of using a live projection. So if you were in a state where you have a lot of writes, but you very rarely read that aggregate, I would tell you it's definitely optimal to use live. Don't make your write operations wait to constantly update, constantly be updating and rewriting the kind of snapshotted version of the aggregate if that aggregate's not used very often. So that's when I would use live. There's also some advantages for whether or not you're needing to migrate previous projections and change projections. There's more to it than that, but loosely, I would oversimplify this as many writes, few reads, use live. Next option, let's go back to the code. Let's do this a little bit differently. So I said, instead, let's say we're going to have that aggregate built up ahead of time. So now I got to come back here. I do need to come back into Martin. I think this is the default, but I'm not going to trust that. So now let's do this differently. By this line of code, now what I'm saying is anytime there are events that are being applied to a stream that involves a driver shift, when you call save changes to commit those events, you're going to reach up, grab the latest version of the aggregate if you don't already have it in memory, apply those events, and persist the new copy. Let's see. And then just to show the corresponding change. So this time, instead of calling aggregate stream, now I'm just going to say load the document. So we're just pretending it's just a normal, in this case, it's just a normal document in Martin. So load async, let's just load this document from its primary key.
Yeah, I think it's interesting because you said earlier, it is different than what people are probably typically thinking of, in the sense of if you're performing a command, you would typically think of replaying all of them at that time, get the stream, get all the events, replay everything in memory. So I know the current state, then I'll apply a command. But because you have immediate consistency of running that and persisting that projection at the same time of appending the event, you don't necessarily have to do that every time. I think the caveat there, like you just were alluding to, is kind of what scenario are you in? Are you in a write heavy, or are you more in not a write heavy where rerunning them at time of executing command and making that state change appending that event isn't as impactful? I would say that's probably the question I get in YouTube absolutely the most related to event sourcing is always, well, what happens if I have a ton of events and I have to replay those all the time?
Yeah.
I think that could be a conversation for an entire different talk, but it's interesting to see that you have these options based on your scenario, I guess. So I'm not the one, I think you were alluding to earlier, oh, maybe some people won't like this. I do, because there's trade-offs, as long as you understand the trade-offs, the situation you're in, and not just immediately think, oh, I have to do it this way. So I think it's beneficial, personally.
I do too. Now, I would say I don't think we're going to get to it today, but Martin does have the ability also. Like if you come in later and you change how this is calculated, like you want to, I don't know what you do, but you do something to change this code such that the application events would be different in the future. Martin has the ability to go and rebuild those projected data that are kind of pre-persisted in the database. But you know, that's a real problem if you have a massive number of events, and that is absolutely on my plate for the calendar year 2023 to optimize that and have a zero downtime rebuild process. So
I think it's interesting. I think I know that there's a subset of people who think, okay, they absolutely have to be asynchronous. However, if you're thinking of it kind of on the read model side, I think people are more apt there to be thinking about it being asynchronous. But if you're thinking of it kind of on the command side, you would be doing snapshots in the exact same. You want to be consistent doing that. So generally, so you'd be doing it at the same time if it's a pending event. I think where the confusion when people get is thinking of projections as being only read model, but you're doing projections when you're also writing, performing a command, so you can get to current state, see, okay, can I actually even append this event? People don't usually often equate a projection in both lights, but they have different use cases. So that's why I see this. That's what I'm kind of alluding to, where I think it makes sense.
Let me show one more projection so we can get a good live version. So we're talking about, oh, I actually like this approach. Hopefully it will get rid of the experimental. Now let's say we want to do some correlation of all the events for different rides and different driver shifts for a particular postal code on a certain date. And we want a full correlated summary view of kind of like a dashboard for administrators, what's going on in the world. So Martin also has the ability to do cross-stream or multi-stream aggregation. So this kind of bigger summations. So without getting too much into the mechanics here, the point is this is pulling data from lots of different streams at a time. This is expensive to build and find, and you have huge concurrency issues because different streams are getting updated simultaneously all the time. There is a long-winded way of saying you never want to use any kind of cross-stream aggregation inline, probably not live either. It's technically possible, but don't unless you have a very small system. So that kind of thing, you absolutely need to do that asynchronously. So that's where you get an eventual consistency. So let me just show the setup of that real quick. And then I've got another work example that comes in play. I gotta do just a little bit more here. Okay. So line of code I just added. That's going to add in a Martin setup. That's going to add a new I-hosted service that's going to run in the background. And that is the look ahead that is trying to calculate, build up asynchronous projections as it goes. And then I need to tell Martin about this. So like I've been saying, this particular aggregation, this is too slow. You don't want to be doing this in line. All kinds of concurrency issues. You really need to have this being built asynchronously. So that's what I'm going to do there. So 2 steps. I have added what we call the async daemon. This is the background process in Martin that is reading the database ahead, finding out where the events are coming in sequentially, and applying these through this aggregation. So that's your eventual consistency. That's the common model you probably see in most event stores. You can absolutely do that with Martin, and you probably should in some cases. My own shop, Meta-Analytics, right now, we've got a use case for a system where it's not using event sourcing at all, but probably should, where tons of events are coming in as medical care workers, taking care of tasks, marking as part of a workflow. But there is a view that is very slow to calculate, and it's impacted every time one of these little operations happen. So today we do it to be consistent. We do it live. It's calculated at the time somebody tries to request that. So in the future, this is a perfect place where you actually do want eventual consistency, where I don't want to calculate that massive, expensive update to this large shared view at the time I'm trying to capture these task completed events. You don't want to make the UI wait and pause for that huge operation. It won't scale. So you want to be able to quickly capture events. And then on the read side, at the same time, when you pull up the place where I need to see the view of the world, this very expensive view, you don't want the UI to just hang for a long time because it's having to calculate this really expensive set of database queries all at once to create it for you. So to improve user interface and web service responsiveness on both ends, you move to a model where that very expensive view updating is happening in background processes. And that's what's going on with the async daemon. And that's why that's actually valuable from a business facing standpoint and scalability. All right. So now getting into some weird special to Martin functionality. Hopefully that connotes speed as the little Martin runs across the snow. So that postal code summary aggregate we just looked at, I did try to say it's slow to build. So we want it building in the background and it's big, but also it is specially designed, just take my word for it. It is specially designed for being used by the user interface. So whatever user interface has a dashboard, let's say we purposely built this to be exactly the JSON package that needs to be sent down to a React, a Vue, an Angular page, or whatever. So this is exactly what I'm making a big point here. This is exactly what we want to send down straight to the UI. So let me show you. All righty. So I'm going to add an add-on here, or I have. So there's another package called martin.ASP.NET Core. It's a very small package, very small NuGet package, but it adds an extension method we're going to use here. So given a small endpoint that takes in, that's really postal code and date, some kind of date format. Derek being a Canadian is probably laughing at us silly Americans doing the month and date backwards. We'll skip over that. Yeah, and next thing you're gonna do is what schedule are we on? So I do need to take in iQuery session. This is .NET 6. When you get to MVC 7, that can go away. That'll be nice. But it's there for right now. So I got a little bit of code just to come up with what the string identifier is for the postal code summary. Once I have that, what I'm doing here, this line of code, so what's going on right here with this little extension method, we're writing directly to the HTTP context. So go look up this document in the database that's in PostgreSQL that's stored as JSON. Don't serialize this into a postal code summary where it's going to be immediately, don't deserialize it just to serialize it again. Don't create strings, don't do anything. Write byte for byte, what's in here, what's in the database as JSON, write it directly out to the HTTP context. And while you're doing that, deal with things like setting the 200, set the content length, the content type, whatever you need to. But this is doing it in the most efficient way possible. If I can just belabor the point here and really pour this on. People say event sourcing is too much work, it's too complicated. And I don't think folks realize how much work in that they're spending with tools like AutoMapper or transforming database entities and the DTOs to send down to view models to send down into web services. If we were building this, let's say Entity Framework Core, SQL Server, in more of a traditional way, what we would be doing potentially is using DB context to issue a request to the database. We're going to get this entity. Maybe that entity has children entities and relationships. So we got to fiddle with what's lazy, what's eager, all that nonsense. EF Core is going to have to build this big, huge SQL statement. Maybe it has joins, all kinds of stuff. The stuff that ORMs do that really makes database purists really angry. So, all that expensive stuff, and it's got a loop around it. It's got to build up the entities. So you're initializing all kinds of objects, and then you got a mapping layer to go from that to what exactly you need. Yeah, I know you could short circuit that by doing a select clause in the link, but let me pour this on. And after all that work, then you're going to build up the view model DTO, and you're immediately going to serialize that to JSON and stream it down to the HTTP context. If you're not careful, maybe you're doing that by first writing a string, which is expensive in memory, so on and so forth. All that huge amount of verbiage is to say a normal web service just to get a resource that's actually very intensive on server resources, especially in serious load. You're allocating tons of objects, destroying objects, you're working the garbage collector, so on and so on. The Martin model, this is the fastest, most efficient way I can possibly think of to deliver write JSON right out to the HTTP outgoing response.
Yeah, I think a way to put this too is most apps, in my experience, not everywhere in an app, but in a lot of places, is usually read heavy. So if you're thinking about having to do that hit your database, if you're using something like EF, it building a model, then you immediately transforming that potentially to another model, then serializing it, and you're doing that at runtime every time, which is read heavy, as opposed to doing it at time of state change via projection and persisting that. You're not having that cost of doing that transformation every time. You're doing it once. So that's how I like to think about it, is just I think you put it well. You're doing a lot of extra work every time, especially if you think about if it's read heavy.
Yeah. Well, and then trying to compare the complexity of event sourcing to a more traditional way, now you got these events, now you got all this projection stuff, but to try to do an apples to apples comparison, you got to consider how much work are you spending transforming the database model to entities to view models, and you got to add that in your comparison to the event source code. All right, just to bring CQRS into it, just kind of come a little more full circle, show things a little more in context of how this is really happening. We've already kind of alluded to the controller method we were looking at before, but just thinking kind of the typical steps you're going to do in accepting a single command. In our case, the accept ride command. You need to establish a transactional boundary. So I'm showing extremely simple code, but a command may select multiple events. Like in a banking world, when you take in a debit account command, you may overdraw. You may get into overdraw situations or something. So there's a little bit of variability of multiple events, potentially 0 to many events getting captured at a time. And that all needs to be done in a transactional way. It needs to all succeed or all fail. This is also going to come into play if you're then raising events that need to be published somewhere else. If we publish a write accepted event, somewhere down the line, something else needs to probably take some extra work of send a text message out or message through the Uber Lyft app that, hey, I'm accepting, I am this car, I'm on my way. But all that needs to be happening transactionally. It needs to succeed or fail. For experienced asynchronous messaging folks, I am clearly kind of heading towards a little bit of a description of an outbox pattern. To decide what events that should be raised, a lot of times you're not inevitably, but pretty often, you're going to need to know the existing write model of the world. So taking the driver shift as the example, when we want to issue the accept ride command, we need to check, was the driver really ready? Because let's just say our rule is we don't let you accept a ride if you are already busy with someone else, even though that's how they work in real life. So we need a write model of at least the bare bone of what the driver shift status is, so we know if something's valid or not. You may have different family members, especially maybe with the ride, but too with the driver. Maybe something's going on in the UI where they're clicking too fast, and they accidentally issue the same command multiple times. Or in other places, maybe there are multiple users hammering on the system at the same time that are trying to make a change to some kind of event source workflow, and the second person's changes would no longer be valid, after the first person that is done, right? That's something we face with the development all the time in a distributed system. So we got to find a way to deal with that, either with optimistic or maybe even pessimistic locking. Finally, business logic: decide what new events should be persisted or should be raised. If you accept a ride accepted. But it may be something like, maybe there's some logic that would say ride rejected. That we text something about the driver or the ride status of the ride that makes us say, no, you can't actually do this. So you got to decide a little bit of workflow. What am I going to do next? And then down at the end, we got to persist the events. That's what Martin's for. We may want to publish some or all of the outgoing events, like maybe another message handler, an event message handler needs to do some additional work down the line. I want to happen asynchronously after this transaction to notify the actual customers, whatever it's going to be. Okay, long-winded. I want to show a couple different versions of this. First, we're going to do this, what we're looking at, longhand way. So we're going to pretend that it's definitely inline. I'm going to load this from the database by its identity. I'm going to do a little bit of validation logic. And if it blows up, the whole thing's over. Otherwise, I'm deciding what events to do. I'm going to append it. And I'm also appending it with optimistic concurrency. So I'm going to show an easier way to do this in just a second. So what I'm doing is I'm telling Martin, hey, the version of the stream should be, at the end of the day, should be this exact version when this is completed. And if not, Martin's going to throw an exception. And it's going to tell you, you have a concurrency violation. And then after that, you may decide to, okay, retry that command again against the new state. Or maybe I say, no, I tell the user to, whatever. All right. So later versions of Martin, just from like this summer on, as in the course of writing up some of these talks, realize sample code, there's a lot of repetitive code. Plus, I think personally, I've had other people disagree. I think the syntax is really, and usage is really confusing. Even though I'm helped write this. So we have a new concept that's called fetch for writing. This is wallpapering it. Is it a live aggregate? Is it a pre-calculated inline aggregate? Who cares? We're going to wallpaper that over for you. So you can change your mind, left, right, whatever you want to do. Who cares? We're going to handle it for you no matter what. And we do this, we're going to do a lot to help you out with the mechanics, setting up the mechanics of doing the optimistic concurrency for you. So as long as you tell us, hey, this is the version of the aggregate that I issued the command against. So you're in the UI, at some point you have the state of the driver shift and the UI knows that it's version 5. You click a button to accept when it sends this command up, to show you. The UI is saying, it's just passing along, this is the version I think the driver shift is at. The point there is, make sure that this command is being applied to the current version of the driver shift you think it is. So just in case you do the trick of double, triple clicking and you send the same command multiple times, it won't process. This will actually stop it from processing multiple times. This could actually reject it. The rejection will happen down here. It's kind of hiding it. So a little special, grabs a new stream object. The stream object comes with the aggregate. I can use this to append more events to it, and then finally save the session. This is doing a lot more work to wire up the the concurrency for us. Yet again, a third option. This is starting to get into the decider pattern. Just kind of a relatively recent idea of event sourcing. I think I associate with the F# community. But having a function that isolate the business logic to a function that, given the current state of the aggregate and this command, tell me what events should be raised next. You don't necessarily take out other actions, but you're deciding what should happen, what are the changes in state, and something else will deal with additional work for, things like the ride accepted. So this is a trying to get to that decider pattern usage. This example of using continuation passing style. This is the exact same functionality we looked at before, but this is it's trying to encapsulate the repetitive go fetch it, then save it. So what you're seeing is the stuff that's in the middle is what happens here. In real usage, what you probably want to do is extract that to probably put that in a separate method, make sure it's public. The hope is here that you could pretty easily unit test this function in isolation, because you are, there's another option where you can just have this return IEnumerable object. But the point is, you can push, here's the current state of the system, and here's the command, tell me what you would have done. No actual hard connection to the database. You could use an in-memory version of this thing just to record what gets done. But the hope is this leads you to an easier unit testing strategy.
Yeah, I love it. I love the idea of, here's a command, here's my event stream of what it was, and now I'm looking at outbound after that. Was the event that I think should be appended, did that happen?
Yes.
It doesn't get, it's, to me, that's glorious. I like, to me, it's awesome to test this way.
Well, let's go just a little bit farther, and then I'll finally quit this. So one last thing. So Martin has a new buddy. So we're going to talk about a new project called Wolverine. It's actually much older than it actually started before Martin, but languished, whatever. So combining Martin and Wolverine into what we are trying to call the critter stack for CQRS. Wolverine is kind of a combination of, for folks that use Jimmy Bogart's Mediator and the more classical message bus tools like In-Service Bus or Mass Transit. What's probably cool about Wolverine has a very unique runtime model that I think is going to give us a lot more opportunity to make the message handling or command handling and event handling be more productive. But big talk, let me try to prove that real quick. So I'll do yet one more version of this, what we did up here. So first, I need to pop in, I need to add Wolverine itself. So I'm going to add just a little bit of code. There's a package called wolverinefx.martin that's going to give you Wolverine itself and then Wolverine's integrations for Martin that we're going to use here. So I've added a couple lines. These are actually Wolverine extension methods. So I'm going to integrate with Wolverine to Martin. This is going to add outbox support to Martin event store. It's going to add, just a durable Postgres back to outbox to Wolverine itself. And then I'm going to opt into event forwarding to Wolverine so that any event type that Wolverine recognizes as, I have a subscriber for this event. Anytime you persist an event with Martin, it's going to relay that message on that event as a message to the proper subscriber in Wolverine, and do so in a durable way with an outbox and all that good stuff. I'm going to get to that in a second. Then I'm also need to add Wolverine itself. Again, hopefully this is very idiomatic .NET Core now. Use Wolverine. This has to be placed on the host builder though. And I'm going to make one little option. This is just making sure it's in completely absolutely completely enrolled in the durable outbox. All right. One last version. So this case, if you're a user or mediator, I think this is going to be kind of close, and I would probably do this in minimal API, but just go with it. So instead of trying to handle things in the controller itself, I'm just going to quickly delegate this accept ride command right to Wolverine. Wolverine has a single entry point now. It's called iMessage bus. So this exposes both asynchronous messaging, publishing, sending, and also the ability to invoke inline. So the kind of the classic mediator functionality. So all I'm going to do is immediately just delegate this to Wolverine. Just go deal with it. I'll return 200 if you don't blow up. Now, so what I'm showing you here, this is the Wolverine message handler that is actually a superset of what we originally did explicitly up here. So validation logic, go find the existing aggregate based on values of the command, decide what events should be done, deal with concurrency, potential concurrency issues for us, persist this in a transactional boundary. But in the Wolverine world, this is closer to a pure decider pattern. It's a little bit of magic going on, but in naming convention, this is static method. It's just a method. A little bit of naming convention. Wolverine, anything that says as a public type that's suffixed as handler, Wolverine thinks that's supposed to be a message handler, and I'm going to go look for any messages called handle. And the first argument is the message type. So no interfaces, no attributes in this case. Naming it aggregate handler with the Martin thing plugged in. This is telling Martin, this is adding a little bit of middleware that's hooking a few more things up. So, and there's more complex usages possible. Let's just go with this for right now. So when this runs at runtime, Wolverine middleware is invoking Martin's fetch for writing based on, it can tell this is the aggregate, the accept ride. I can tell by the naming convention here that this is going to be the identity of the driver shift aggregate we're trying to load. So middleware can use that. It also knows that an integer or long property named version, that's the aggregate version. So all behind the scenes is loading the aggregate for you, taking in the command. All you need to do is this code right here, giving a command, giving the aggregate. You could potentially use other services here, right? Wolverine accepts method injection just the same way minimal API or the new MVC Core 7. That's a great addition in my opinion, by the way. I could, and I just need to decide what am I returning. And the Wolverine Martin combination, it's going to apply any objects that come out of here. It's going to assume these are events. It's going to be appended to the stream. It's going to be persisted in one transaction. Part of that transaction is a durable outbox as well. So any events that are known by Wolverine to be, I've got a subscriber for this. I keep saying if we try to append a ride accepted event, then let's say there's going to be a handler somewhere else, a subscriber that's going to take that and it's going to message the actual customers, hey, your ride is on the way. So all of that is happening around this code. The durable outbox, just in case you're not familiar with it, it's persisting the changes to capture the event, potentially changing a driver shift aggregate. And it's also persisting copies of any outgoing messages in the database, all in one transaction. If the transaction succeeds, then a background process in Wolverine is trying to kick those outgoing messages out. And it's done so in a way that the message is going to get out there at least once, one way or another. Even if the whole process dies, it'll happen on another node or you restart it. But the point being, the durable outbox is going to make sure your message gets out as long as the initial database transaction succeeds. So all that being said, Derek, this is my hope. I mean, this is our the full Martin core team. This is our vision and hope for what CQRS with Martin is going to look like in the long run. Get it to the point where we can really boil down your command handlers to this.
Yeah, it's interesting. It's instead of having kind of interface markers and going purely by convention, the way I always say this is I always say that if you have a class with one method, you have a function, and that's most of the times what all you really want. With the idea of, I think people can get behind method injection, hopefully, when they see it like this, or when they see it with, ASP.NET Core, like minimal APIs, like you said, MVC. You can use a static class. You know what I mean? Like, to me, this is getting rid of the cruft that you feel like you're repetitively doing, hence why you probably came up with doing it after writing the same cruft over and over again. I wouldn't call it cruft. It's just very repetitive. So the idea of being able to accept that aggregate, not have to load it because you know you're loading it, being able to use a static class, and like you said, you can inject whatever else you need to inject, and Wolverine will do that for you. To me, it makes a lot of sense. I can see how, like anything, people's familiarity with, okay, but I have a class, I have to do constructor injection.
Yeah.
Like, no, you don't actually. They may be familiar with what you're doing, but there's got to be a lot of memory benefits to having static classes here as well.
There are, and that's actually why it is exactly why it is a static. It's trying to, it's a lot of silly micro optimizations, but so this is generating code at runtime, and it's trying to do so. It's trying to do so in a way to minimize object allocations.
Yeah.
So,
I mean, that might have been your intent. I view that as like secondary almost. Like, it's a secondary benefit. To me, it's just like actually developer experience writing this. That's my first inclination. Not necessarily, you may be thinking, oh, okay, well, yeah, I know if I do it the typical way is what you'd probably think of. There's going to be a lot of allocations there, so that was your primary reason potentially.
Well, it wasn't mine
the
only reason.
Like, I just look at this thinking, yeah, like this, it's getting to the point of what I actually care about.
Yeah. So, following that theme, we're gonna push this a lot, try to push this a lot farther next year. Get you to the point where you're worried about business logic or in other places, being able to pay attention to data access, but hopefully not at the same time. So the stuff that's vital and special about your application, and try to get the grubby, repetitive infrastructure code, try to get that out of your way. Appreciate your feedback, and I would love to get this in front of more people and see what other people think.
I want to thank Jeremy for taking the time. I really do appreciate it on presenting about Martin and event sourcing. If you have any thoughts or questions about Martin and this topic, make sure to leave a comment. I will, as always, will be replying, and I'll post anything to Jeremy as well that he can reply to. If you have any thoughts, make sure to leave those. If you enjoyed this video, please give it a thumbs up, and please subscribe for more videos on software architecture and design. Thanks.